Okay, so here's how we're going to go through the answer key to the practice quiz that you guys just took. So the very first set of questions was about identifying bond type and then explaining what happens in those bond types. So in the case of phosphorus and oxygen, is there a metal present? The answer is no. So then you have to go ahead and calculate the electronegativity difference. And in this case, the electronegativity difference ends up being 1.4. That should tell you that it is a covalent bond. Specifically, it is a polar covalent bond. What you should also be able to tell me is that the electrons are shared unequally toward, in this case, it's going to go toward the oxygen, because the oxygen is the more electronegative atom. With potassium and iodine, in this case, the potassium is your metal. So as a result of the potassium being your metal, that should tell you that that you don't need to do an electronegativity difference, and that should also tell you that this is an ionic bond. Okay, and you should also be able to tell me that in an ionic bond, electrons are transferred. In this case, it's going to be from potassium, the metal, to iodine, the nonmetal. So you need both of those components to get full credit for this tomorrow. The next question was asking you to determine what type of covalent bond is present. So in this instance, we have carbon and sulfur versus hydrogen and chlorine. In the carbon and sulfur bond, the electronegativity difference is 0.0. So that tells me this is going to be a non-polar covalent bond. And if I were to draw this structure, I would simply draw carbon and sulfur, and I would draw a bond in between them, and that's it. So I don't need dipole arrows because it's a nonpolar covalent bond. I don't need partial charges because it's a nonpolar covalent bond. In the example of hydrogen and chlorine, though, 2.1 minus 3.0 gives you 0.9. So that gives you a polar covalent bond. And because it's a polar covalent bond, I do need to draw dipole arrows. So we're looking at the relationship between hydrogen and chlorine, and there's a dipole, I drew my single bond there. But now we always draw our dipole arrow toward the more electronegative atom. So in this case, the more electronegative atom is the chlorine, so my arrow points that way. We also are going to use our partial charges, and our partial charges are delta negative and delta positive. Delta negative is always on the more electronegative element, and delta positive is on the more or the less or the more positive or the less electronegative element. So that's what you needed to have both of those things. I know it says dipole arrows or partial charges if needed, but just to be safe, I draw them both. Questions here? The next part of this was some nomenclature. So you had CF4. There's no subscript behind the carbon, so you just write carbon. The 4 tells you that there are 4 fluorines, and the prefix for 4 is tetra. So it's tetrafluor. We drop the INE and it becomes tetrafluoride. In P2O3, the 2 tells you there's 2 phosphoruses, so it's diphosphorus. The 3 tells you there's 3 oxygens, so it's triox. Drop the ending for oxygen and add IDE, so it's trioxide. Questions about that? In the next one, you're writing the formula from the name. Diselenium. Di should tell you that there's 2 selenium, so I get Se2. And then dibromide tells me that there's 2 bromines, so I wrote Br2, left it as it is. Nitrogen trichloride. Yes, sir? Sure. Nitrogen trichloride. Nitrogen trichloride, there's no prefix in front of nitrogen, so it tells me there's one nitrogen, so just N. And tri tells me there's three chlorines, so it's so it's Cl3. Questions? Drawing Lewis structures. At this point, we've drawn so many Lewis structures. Many of you look like you're becoming pros at it, which is great. So we're going to continue on with that pattern here, and hopefully you guys did well with this. Here you have OCl2. There's one oxygen. Verford. Sure. Yep. Apparently, so there's one oxygen with 6 valence electrons, and there's 2 chlorines with 7 valence electrons each for 14. 6 and 14 is 20. So I'm going to start by taking my oxygen and placing it as my central atom. I'm going to add chlorine to both sides, and then I'm going to start by adding single bonds. Those single bonds are 2 electrons each, so 4. So that means I have 16 electrons to still find a home for. So 2, 4, 6, 8, 10, 12, 14, 16. Then I go and I check to see if each atom has 8 valence electrons. The chlorine has 1 bond with 2 electrons and 6 dots, so that has 8. And the oxygen has 2 bonds with 2 electrons each, so that's 4, plus 4 more dots, so that's 8 electrons. So each atom has 8 valence electrons, and so this is the best structure we can draw. In the case of CCl4, 1 carbon with 4 valence electrons, 4 chlorines with 7 valence electrons each for 28. 4 and 28 is 32. So I'm going to start by drawing my central atom, which is going to be carbon, along with chlorine, like so. And then I'm going to single bond them together. Each single bond is 2 electrons, and I've used 4 of them, so that's going to be taking 8 away. So now I have 24 valence electrons, so I'm going to start placing them. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm going to check and see if each atom has 8 electrons. So chlorine has 1 bond with 2 electrons and 6 dots. So all the chlorines have 8 valence electrons. Carbon has 4 bonds with 2, 4, 6, 8 electrons in each. So carbon has its 8 valence electrons. So in this instance, that's the best structure we can draw. Questions about this one? All right. The next one, we're drawing polyatomic ions. So we have silicon and oxygen. Silicon has 4 valence electrons. Oxygen has 6 valence electrons times 4, which is 24. That adds up to 28. Because this is a polyatomic ion, it has a charge of -4. The charge of -4 means I'm going to add 4 more electrons to the 28 to get 32. So now I'm going to draw my structure. So I'm going to take silicon and put it in the middle. I'm going to put my 4 oxygens around it and bond them to silicon with single bonds to start. So I've used 2, 4, 6, 8. So that means that I have 24 electrons left. So I'm going to start putting pairs of electrons around the oxygen. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So now I've used all of my electrons, so I'm going to go ahead and check. I have oxygen has 1 bond with 2 electrons and 6 dots, so that's 8 electrons. All of the oxygens are like that. My silicon has 4 bonds with 2 electrons each, so that's 8 electrons. So each atom has 8 electrons, valence electrons around it. The last thing that we have to do is, because this is a polyatomic ion, we've got to put this into brackets and write the charge. If you do not put it into brackets and write the charge, I end up having to take some points off, even if you've done all of the rest of the work correctly. Questions? The next one is to identify the shape based on what you're given. And on yours, it says linear, trigonal planar, bent, tetrahedral, and trigonal planar. It should say trigonal pyramidal. When I made copies of this for tomorrow, it is fixed. but you have to figure out the correct shape. So in this case, I'm going to go through like my checklist in my head. X is my central atom, so that's an A. I have two atoms, the Z and the Z, bonded to it, so it's an AX2. And there are two pairs of unshared electrons on the central atom, so it's an AX2E2. Hopefully you recall that to be a bent molecule. In the case of the second one, we have our central atom, which is D, so that's A. We have three atoms bonded to the central atom, so that's X3. And in this case, there are no unshared pairs of electrons on the central atom, so that's E0. And hopefully you recall that to be trigonal planar. Questions about that? All right. The next part of this is you had to identify the molecular polarity and to give us some type of explanation. So in this case, you didn't have to draw the structure. You didn't have to identify if the bonds are polar or nonpolar. You didn't have to come up with the Vesper geometry because we gave it all to you. The nitrogen and fluorine bond is a polar covalent bond. The hydrogen and nitrogen bond, hopefully you identified to be a nonpolar covalent bond because it didn't have the dipole arrows on it. Now, it's also trigonal pyramidal, which is kind of important. So what I'm going to make the point of here is that this is a polar molecule. Now, there's two reasons why this is a polar molecule, and I'm going to make the point. I'm going to explain both of them. So the first reason is that it's a polar molecule because there is an unshared pair of electrons on the central atom, creating a large area of negative charge. On the central atom. The other reason why this is a polar molecule is because the dipole arrows don't cancel out. So none of the dipole arrows Now, if this is the question on the quiz tomorrow, you would need to come up with both of those things. You would have to say that there's an unshared pair of electrons on the central atom that creates a large area of negative charge, and that none of the dipole arrows cancel out. So please, 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 please be thinking about these things when you are coming up with your explanation as to whether or not this is a polar or nonpolar molecule. Questions?
So for nonpolar, the arrows will cancel out?
If it's nonpolar, if there's dipole arrows, the arrows will cancel out, yes. Okay. However, if like on this one, if the arrows did cancel out, but there was the unshared pair of electrons, it would still be polar. Okay. In this one here, you are asked to identify the electron deficient element or the electron deficient compound. Okay. OCl2 can't be expanded or deficient. PCl6 can be expanded. BeF2 is going to be your electron deficient one. Remember that beryllium only has 2 valence electrons, and it needs 4 valence electrons. So it's one of the few that don't need 8. So if I was to draw this structure with beryllium bringing 2 valence electrons and fluorine bringing 7 times 2 of them, which is 14, I would draw something that looks like this. Start with a single bond. And so at this point, I've used 2 4 electrons. So that's going to leave me with 12 valence electrons. And now I'm going to start finding homes. So by putting pairs, so 2, 4, 6, 8, 10, 12. Now, my fluorine has 1 dash, which is 2 electrons, and 6 dots, which gets me up to 8 valence electrons. So both of my fluorines have the correct number of valence electrons, and beryllium has 2 dashes, which are 2 4 electrons, and that's the number of valence electrons that beryllium needs. So in this case here, all of the atoms have the correct number of valence electrons. Questions? The next one is about drawing resonance structures for molecules. So in this case, we have NO3 minus 1. We have nitrogen, which has 5 valence electrons, and oxygen, which has 6 valence electrons times the 3 of them. So that means we have 18 valence electrons plus the 5, which is 23. The charge on this polyatomic ion is a minus 1, so we're going to add electrons, so it's 24 valence electrons. So when I go to first draw this structure, I'm going to draw it looking like this. So I'm going to have nitrogen in the middle and my oxygens around it. And I'm going to add single bonds. And when I add single bonds, I've used 6, so that leaves me with 18 valence electrons. So I'm going to go 2, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now I've used all of my electrons, and my oxygens have 8 valence electrons, 1 dash and 6 dots, but my nitrogen only has 6, 3 dashes. And I don't have any electrons to add, so the only way to do that is for me to go ahead and create a multiple bond. So I'm going to take like these two and throw that right there. So I'm going to clean this up real quick for you once. So I'm going to have so when I clean it up, it's going to look a little something like this. And then it's going to have its multiple bond, and then you're going to have to remember to put this into brackets. So, and because it's a resonance structure, I have to draw all of the other possible combinations for this. So when I go to draw all the other possible combinations for this, they would look something like this. Note that I am being careful to put only 4 electrons around the oxygen that has a double bond because I don't want to have too many oxygens around that, or electrons around that oxygen. And then I've got one more structure to draw, so I'm going to kind of try to do this down here because I clearly didn't plan this out well. And note that because this is a polyatomic ion, I had to put each of them into brackets. And then the last thing that's going to be like really important here, and it feels kind of nitpicky when I say it out loud, but it is going to be kind of important, is that you have to put these double-headed arrows here. If you don't, I take points off, not a ton, but I take some points off because that's how we indicate that these 3 structures are resonance structures. Questions? Okay. The second to last one was identifying the preferred structure based on formal charge. Now remember, formal charge is number of valence electrons minus number of bonds minus number of dots. And the directions say you only have to show the calculation for at least one atom. I'm going to show them for all of the atoms so that we see where I'm getting my information from. But Nitrogen has 5 valence electrons minus, it's participating in 2 bonds minus 4 dots, right? So nitrogen is 5 minus 2, which is 3, minus 4, which is minus 1. So nitrogen is in a minus 1. We then have carbon, which has 4 valence electrons minus 4 bonds minus 0 dots. So carbon ends up being 0 for its formal charge. And then sulfur has 6 valence electrons minus 2 bonds minus 4 dots. So sulfur is 6 minus 4 is 2, minus 2 is 0. So we get 0. And when I add this up, I get -1 plus 0 is equal to -1 for the structure's formal charge. Over here, I've got carbon, which has 4 valence electrons minus 2 bonds minus 4 dots. So carbon in this case is 4 minus 4 is 0, minus 2 is minus 2. Nitrogen has 5 valence electrons minus, in this case, 4 bonds minus 0 dots. So nitrogen is going to be minus 1. And then sulfur has 6 valence electrons.
Wouldn't it just be positive 1 for nitrogen?
That's what I said. Thank you for making sure that's what I said. Sulfur has 6 valence electrons minus 2 bonds minus 4 dots. So sulfur's total charge there is going to be 0. Now in this case, -2 plus 1 plus 0 is still -1. So the most preferred structure here is going to be this one over here. And this is going to be the preferred structure. Because even though they both add up to 0, the formal charges of the individual atoms are lowest or closest to 0 on that structure. Yes.
Wouldn't that already be the preferred structure since carbon is in the middle?
Sometimes, most of the time true, but not always. Okay. Last one. Your job was to identify which one of these is trigonal bipyramidal. And in this case here, it's going to be that structure right there. What am I looking for you to tell me is that we have a central atom with 5 atoms bonded to it. The central atom. And no unshared pairs of electrons on the central atom. So that's how I would answer a question like that. Any other questions about this particular practice quiz? All right. Study a little bit tonight. Good luck.